Welcome back. This week we are going to review the functional paradigm. Specifically, we are going to learn how to program with Lisp. Lisp is one of the most used programming languages that follow the functional paradigm. The meaning of Lisp is list processing, and the reason is because everything is a list, and I'm going to talk more about that later. But remember, everything is a list. Lisp uses an interpreter, so your first homework for this week is to install an interpreter for Lisp. Because Lisp uses an interpreter, we're going to have automatic management of the memory, so we can forget about pointers and news and deletes. One of the most important features of the functional paradigm is the level of abstraction. Functional programming is more abstract than imperative and object-oriented programming. Particularly, we do not have data types, and the syntax is going to be simpler. We're going to review several examples. First, you need an interpreter. So, three options. I recommend you to install Lisp Work. This is the link. This will provide you with an interpreter that you can use in your computers. It is available for Mac and Windows, so it's a good choice. The personal edition is free, but you need to register and provide an email. Also, you have the option to work online. There is an online Lisp compiler in this address. I recommend that as a plan B. The last one is an old version of a Lisp interpreter. I noticed that it didn't work with Windows 10, but if you're using Linux, maybe you want to take a look. In functional programming, every single instruction in the program is a list. A list is a group of elements enclosed in parentheses. Particularly, we use list to represent functions. A function is a list in which the first element of the list is the ID of the function, and the other elements are parameters of the function. Inside of the list, white spaces separate each of the list elements. So, for instance, the following three lines are three lists, and those three lists represent three functions. The first element in each list, print, plus sign, and SQRT, represent IDs of a particular function. The next elements are parameters for that function. Hello world is a string, so it's one item and is one parameter for the function print. In the second line, 2 and 2, there are numbers, integers, and they are two parameters for the function that have as an ID the plus symbol. Finally, in the last line, the number 2 is a parameter for the function SQRT. Important thing to notice, there are no commas and no semicolons at the end. We are going to talk about data later, but one of the most important features in functional programming is that the instructions, functions, and the data are represented using exactly the same general format, list. So let us focus on the instructions first. Remember, parentheses, and inside the first element is the ID of the function, and then you can have parameters, any number of parameters. The first thing that you are going to notice is there are not operators in Lisp. They are functions. Therefore, you can use, like in the example, the plus, the asterisk, and that means addition and multiplication. And then you can put as many parameters as you want. So you can do 3 plus 2 plus 7 plus 9 with only one plus symbol. Or you can use the binary format, providing two parameters, like with the multiplication. The 4 and the 2.3 are the numbers that are being multiplied. In Lisp, the comments begin with the semicolon. We use the semicolon at the first character in comments. So the only reason because I have here semicolons is because I am starting comments. I'm going to try to put comments on the examples to put a note about what is happening. Now, what happens if we want to execute these instructions? Well, step number one, open the interpreter. The Lisp interpreter runs a program line by line. So if you write any of these lines and just press enter, the interpreter is going to show you the result. This is the graphical user interface for Lisp work. So as you notice, you have the prompt and you can start writing your program immediately. So always parentheses, open and close. The tool is going to help you to be sure that you have as many open and closing parentheses as you need. They are going to be in green. So inside I can put the first element is going to be the name of the function, like plus, and then I can put as many parameters as I want. So like this. And remember, the white space is the delimiter. No need for commas. And when you press enter, you just have the result. But also, if you want to do only with 2 parameters, you can do something like this, and this is the result immediately. Obviously, you have the plus, you have multiplication, and you have other functions that have IDs that are words. For instance, you will need later this one, print, and one parameter that is a string, hello world. And you have hello world twice. The first one is the result of the print, is printing hello world. The second one is, as before, the interpreter showing us the result of the line. So one is because the instruction, the second one is the interpreter giving us feedback about what we are doing. Because you're familiar with programming, you will understand what is going to happen here. I can use print, and instead of hello world, I can use another list, another function as a parameter, like this one. So I have this instruction with the ID plus, the parameters are 2 and 2, so that is going to do the addition of 2 plus 2, and then the result is going to be the parameter for the instruction print. Now, as you notice, we have the 4 twice. The first one is the result of print, the second one, the feedback that the interpreter is giving to me about what is happening in the line. Let me show you the online interpreter. Be careful if you use the online interpreter, because in the online interpreter, you are not going to have feedback about what is happening in each line. The only thing that you are going to be able to do is to run your program. So for instance, in the online, if you do the same that we did before, something like this is one line. And then in order to execute, you need to press the button here, run it, and after run it, you do not have output. The output should be here. And you do not have an output because you are not asking to print something as an output. And the online version do not show you feedback about what is happening with your line. So for the online, you will need to use print and your instruction as a parameter. So now, if you run this, you have the result here. And in the online version, if you do a print, and now you do the hello world, you will have hello world only one time. Again, there is no feedback about the line, so use the instruction running and hit the result of the output. Function IDs are called symbols. They are a group of characters, any character except white spaces, obviously because we use the white space as a delimiter, except parentheses because we use the parentheses to enclose the list, the full line. We can neither use pound, quote, double quote, period, or back quote. However, we can use almost any other character. Usually, we do not use numbers alone, and there is pretty common to use hyphens or asterisk. As I mentioned before, there are not operators, so most of the symbols that we know as operators are going to be function IDs for a function that replaces the operator. Finally, functions ID symbols are case insensitive, so that means that you can write the name of a function using uppercase, lowercase, or a combination, and the meaning will be exactly the same. As parameters, we can use list, as I showed you before, but also we can use atomic expressions. Atomic expressions represent primitive data, and we have the following. We have numbers, integers, positive and negative. We have floating point numbers. We have big integers. So this line here represents an integer. That is perfectly correct in Lisp. If you try to store one integer like this in Java, C, or C++, you are going to have problems. But in Lisp, it's perfectly fine. We have complex numbers. The notation for complex numbers is the sharp, the C, and then between parentheses, two numbers that represent the real and the imaginary part. So for instance here, this is the complex number 3.2 plus 2i. We have fractions. So this 2 division 3 is not a division, but is the fraction 2/3. Moreover, we can express the floating point numbers using the notation E, as we do before in other languages. Characters do not use the quote symbol. We're going to use the quote for something different. So the characters in Lisp begin with the sharp and the backslash, and then the character. So the character G is sharp backslash G. The character open curly bracket is sharp backslash open curly bracket. The character backslash is sharp backslash, and so on. We have the escape sequence. So we have the tab, the new line, the space, backspace, and escape. And basically what we do is to use the sharp, the backslash, and then the name of that escape sequence. So notice the sharp C for complex numbers and the sharp backslash for characters. We have strings as usual inside of double quotation marks. Also, as usual, if we want to use the character double quotation mark inside of a string, we use the backslash double quotation mark, like in this line. Or if we want to use the backslash inside of a string, we put double backslash, like here. Finally, we have true and false. True is just the letter T, and false will be represented by the constant nil. Let me show you more examples. Let's review. First, here, the function is plus, so we are doing an addition, but we are adding two fractions. Again, the slash here is not a division. We are doing the addition of two fractions. And the result, if you run that line, is going to be a fraction. This is going to be the result. In the next example, we are doing the multiplication of two floating point numbers. The result is going to be a floating point number. In the next example, we are doing the multiplication of four numbers. And as you notice, there are two positive floating point numbers, then a negative floating point number, and then a fraction. The result of that multiplication is going to be this floating point number, and it's going to be negative. In the next example, we have a division. We are doing the division of 3 and 5, and the result is going to be a fraction, 3/5, which makes sense. So the types are going to stay as general as possible. In the next example, if you try to do the same, but the first number is now floating point, so 3.0 division 5, the result is going to be a floating point number, because Lisp do the operation with floating point numbers. Finally, the last one, 1 plus those two characters, the 1 and the plus symbol together, are the ID of a function, and we have only one parameter, and the parameter is the number 3. And you can get what is happening. The function 1 plus add 1 to the parameter. So in this case, the result is 4, 3 plus 1. This is the equivalent of the plus plus that we use in Java, and that is also available in C and C++. In this example, string uppercase is the ID of the function. Notice the hyphen. This function transforms to uppercase the string that we pass as a parameter, as you can notice. Reverse is another function that works with the strings, and you can figure out what is happening there. Length also works with strings and return the size of the string. Here, notice for the function ID SER240, I am showing that is not case sensitive. As you notice in the last example, SER240 is a mixture of uppercase and lowercase, but Lisp don't care about the uppercases and lowercases. So if you do SER240 of -1.0, the result is the same, doesn't matter the uppercases or lowercases. Moreover, you are doing the square root of a negative number, therefore the result is a complex number. Functions that provide as a result true or false are called predicates. That is the case of the relational operators. For instance, equal. Notice that the function equal that we use to compare two values is with only one equal symbol, but is equivalent to the use of two equals together, like we did in Java, C, and C++. The assignment, do not use the equal operator in Lisp. We're going to have a different instruction for that. So the equal alone means the comparison of two values. In this example, because they are different, the return is false, and therefore in Lisp, nil. We have also the less than and greater than symbols. So in this case, 3 less than 9 is true, so the result is t. We have functions to ask if a parameter is a number, and also to ask if, in particular, a parameter is an odd number. And they return nil or t. When you have an error in your program, the execution is going to stop, So for instance, a division by 0 is going to stop the program, or if you call a function that is not defined, that is going to be an error. For instance, here, this sentence is calling a function that has as an ID blah blah blah, and is using as a parameters two integers, numbers 1 and 0, and one string. Because that function do not exist, you are going to receive an error message. As shown before, you can use list as a parameters, and the evaluation of that is going to be recursive. The lists that are inside are going to be evaluated first, and then their result is going to be used as a parameters for the other list. So in the first example here, you do first the multiplication of two numbers, and the result is going to be used as a parameter for the addition. In the second example, you do first length. So the length of the hello world string is going to be added to the number 44. That will be 11 plus 44. This example here is equivalent to this in Java or C or C++. You would like to review this equivalence between the Lisp notation and the meaning of the expression in the languages that you know. You can use big integers as parameters to any mathematical expression, which is an advantage in Lisp. And you can use enters and white spaces to organize your functions. Like this one is use one big function, but using several lines allow us to understand better what is happening there. So one expression can have multiple lines. One important thing to notice is that the evaluation of mathematical expressions is not perfect. So like in this example, we are playing with trigonometric functions, and even though the result should be 1, we obtain 1.0000001. In these examples, I would like to highlight the fact that we have logic operators. So we have and not, and they are not symbols but words. So this expression here is equivalent to the one in the comment expressed as you do with Java, C or C++. Moreover, notice that the operator greater than or equal exists in Lisp. You have those two symbols together, greater than and equal, as the name of a function. As mentioned before, I would like to advise you to review this and become familiar with this notation. I already explained this example with the print, and the reason because you will get twice the value on the screen if you are using the interpreter, not the online, but the local interpreter. And finally, this one is one more example in which you are using as parameters integers, but the final result is a fraction. Good. Let's stop here, practice with the interpreter, review the examples, and you can start with question 1 and 2 in the homework document. See you next video.